This problem here, number 6 in section 5.1, asks you whether the following functions are exponential functions or not. So their definition is slightly loose compared to what we have. Their definition of exponential functions still have a base, still have a variable on the shoulder, but they do accept you have some kind of coefficient in the front, which is understandable because technically constant coefficient can be observed in, just choose the right exponent, because a can always be phrased as b log b of a. Therefore, a times b to the x can be always be phrased as b log ba times b to the x, hence b x plus log ba. Therefore, that's why some book accepts this definition as exponential function, which doesn't look identical to what we have, but what's not clearly spoke out is that function looks like this, can be phrased as b with some kind of variable on the shoulder. Okay, so let's go ahead and get started, see if all the problems can be structured like that. Well, first of all, this is not an exponential function because clearly my base is not a constant, so that's not okay. The next problem is having the same issue. I have a constant. My variable is, my exponent is not a variable, and this is a variable in the base. So this technically is a linear function, so it's not exponential as well. The first one, if you want, it can be treated as a power structure if you want, or at least similar to a power structure. The next problem, if you rephrase it a little bit, it's 2 times 1 over 0.2 t, which is 2 times 0.2 to the negative t, which is the same as 2 times 0.2 to the negative 1 t, which is 2 times 5 to the power of t. Therefore, it is an exponential function. It is an exponential function. The structure makes sense. The next problem, well, this potentially is the simplest one. It's a constant. It's a constant on the base. It's a variable on the shoulder. So yes, it is an exponential function. The next problem, as a matter of fact, is not exponential, and actually we can't classify it because you have multiple base and they cannot be combined. Okay, but if I had a quick variation of the problem, just for the sake of discussion, if I had 3 times t times 3 to the t times 2 to the t, I'm going to be able to call it 3 times 2 to the t, which is 6 to the t. This is, yes, it is an exponential function, but summation doesn't really work. Along the same line of thinking, division would also work. It's 3 over 2 to the power of t, so yes, this is also an exponential function. The last problem is also an exponential function. The reason I claim that, you may say, okay, your exponent is not really a variable. It's because this problem can be phrased as 0.5, 3 to the power of 0.75 to the power of t. Therefore, this is your a, this is your b, that is your variable x. So it's matched with the structure we wanted to have. So this is an exponential function. So hopefully this addresses your concerns a little bit.